Hey everyone, welcome back to the Cloud Safari series. This time we are embarking on an exciting journey to discover how to set up and manage Amazon EMR. So let's get started. Amazon EMR is a fully managed service provided by AWS for processing large amounts of data quickly and cost-effectively across scalable clusters of virtual servers. It supports big data frameworks like Apache Hadoop, Spark, Hive, HBase, Flink, and more, making it ideal for data analytics, machine learning, ETL workloads, and real-time streaming. EMR simplifies the complexities of setting up and managing these big data tools, automating tasks such as cluster provisioning, configuration, and scaling. So let's discuss some use cases of EMR. First one is big data processing, used for data transformation and processing of large data sets. Second one is data analytics, analyze large data sets using frameworks like Apache Spark. Third one is machine learning, run machine learning algorithm at scale. And fourth one is real-time analytics. It processes streaming data with tools like Apache Flink. Let's discuss some features of Amazon EMR. First one is managed clusters. Amazon EMR fully manages the lifecycle of clusters from provisioning to scaling and termination. Second one is support for popular big data frameworks. EMR supports popular open source big data frameworks like Apache Hadoop, Spark, HBase, and more, making it easy to process large data sets. Third one is integration with AWS services. Use services like S3, Redshift, RDS, Amazon DynamoDB, and AWS Glue. Fourth one is data processing and analytics. Ideal for processing large volumes of data in batch, making it suitable for tasks like ETL, log analysis, and data warehousing. Fifth one is multi-language support. So it supports programming in Python, Java, Scala, and R, enabling flexibility in coding for different teams and skill sets. This Terraform configuration creates a secure S3 bucket, encrypts data, and uploads file to the bucket using null resource. It uses AWS EMR for large-scale data processing by storing input and output data in S3, ensuring secure and efficient storage. The bucket is configured with strict secure policies, including encryption and public access prevention, to meet compliance and security standards for EMR workloads. Now moving on to EMR. In this section, we are using the EMR module, which simplifies the process of creating an EMR cluster in AWS. And then here defines the name of the EMR cluster. Then release label specifies the version of EMR to use. And then this section installs the Apache Spark and Hadoop on the EMR cluster. These are popular frameworks for big data processing. And then this idle timeout automatically terminates the cluster after 8 hours of inactivity to save cost. You can customize this. And then the step, this defines the Spark job that processes data from Amazon S3. The null resource handles the initial upload of input data to S3 and can also manage uploading output files back to the same S3 bucket after the Spark job completes. And then here is the configuration JSON. This custom configuration settings for Spark and Hadoop. In this case, we set Java Home to use Java 8 for both environments. And then moving forward, there is master instance fleet. The master node is provisioned with one M5 X large instance, and then there is core instance fleet. This is also using the same instance type. Also, it is using the spot instances to reduce cost. Spot instances are typically cheaper but can be interrupted, so they are ideal for non-critical workloads. So this grants EMR cluster necessary permissions to access AWS services such as S3 and EC2. And then there is EBS root volume. This specifies the site of the root volume for the EC2 instances. And then EC2 attributes. This defines the subnet IDs where the EMR instances will be launched, typically within a VPC. Moving forward, there is a log URI. So in this, logs are stored in an S3 bucket for easy access and troubleshooting. And then there is termination protection. This protects the cluster from being accidentally terminated. And then there is scale down behavior. This controls how the cluster scales down when there are no tasks running. And then there is a step concurrency level. So this defines how many steps can run concurrently on the cluster. And then there is managed scaling policy. So this configuration automatically adjusts the capacity of your cluster based on workload requirements, ensuring you only use the necessary resources which help optimize. So to summarize this EMR project, Amazon EMR is being configured here using Terraform to automate the creation of an EMR cluster with Apache Spark and Hadoop. So we are using Spot instances for cost saving, S3 for data storage, and IAM policies for secure access. The job we have defined will process data from an S3 bucket using a Spark script and output the results back into S3. So inside the app directory, there is another directory called input. So this contains the CSV file that is being uploaded to the S3 bucket, and then there is script. So this will convert the CSV file into Parquet. This is also being uploaded to the S3, and then the output will be also uploaded to the same S3 bucket inside the directory called output. Now it's time to apply the Terraform. First, we need to perform the Terraform init. This will initialize it. It will take some time. So the Terraform initialization is in process. So after this, we will plan the Terraform to see what infrastructure is this Terraform going to create. So for that, Terraform plan, as we are passing our variable from the prod.tf-vars, so we will also write here variable -file is equals to prod.tf-vars. So it will also take some time. So the Terraform plan has been completed. So we can actually see what it is going to create. So you can actually see from here. Now the final step is Terraform apply, which will apply all the Terraform infrastructure, which will create EMR, S3 and everything in the AWS console. So the command is Terraform apply, same as previous, var file equals to prod.tf-vars, enter. So now it will ask us to type yes if we want to create the infrastructure. After typing yes, it will start creating all the infrastructure. As you can see here, it is creating. It will take some time. Now that we have successfully run Terraform apply, the infrastructure has been created. Let's take a look at the console to verify that everything has been set up as expected. Here in the AWS management console, navigate to the EMR section. You should see a new EMR cluster listed here, which is in the waiting state. So let's click on that. Now, after clicking, we can see all the details such as cluster configuration, instances and logs in this space. So you can also start submitting jobs to run your EMR cluster. Next, we go ahead and interact with the cluster, whether it's submitting Spark jobs or any other data processing tasks that we set up. Everything is now provisioned and ready for use. So now let's go to the step section. Here, the step that I have submitted is completed. The name is process data directly from the Amazon S3. As we have submitted the CSV file, so it has converted that CSV file into Parquet. So we can actually see that in the S3 console. The output is stored in the S3 bucket. As we can see here, EMRDV, the bucket. So here we have uploaded the input before, and the logs of the EMR are also stored in the same S3 bucket. And then this is the script that will convert the CSV file that we have provided into Parquet, and this is the output. Let's see. So the output has been success, and this is the Parquet file that has been stored in the S3. So EMR will take the input from S3, and it will also provide the output to the S3 bucket only, so we can access from the S3 bucket. So in summary, the EMR project processes data by retrieving it from an S3 bucket, performing computations using frameworks like Apache Spark or Hadoop, and then storing the output back in S3. This setup offers scalability, cost effectiveness, and seamless integration with other AWS services, making it ideal for large-scale data processing tasks. That's it for today. Thank you so much for tuning in. I appreciate your time and I hope you found this video useful. See you next time.